I hope you still remember we have the referential integrated constraint in covering in the ER model, right? So when we're referring to some entities in other tables, we need to make sure the entity we are referencing to is unique and also exists. It's not a null, right? So it is very similar here. For the referential integrated constraint, we have similar grammars in the SQL to model this constraint as well. And this can also serve as a motivation for the foreign keys we introduced in the previous page, why we have to use this foreign key and references in the table creation. It can help us maintain healthy database tables. It can also help maintain the referential integrated constraints as well. So in this page, let's assume we consider relation the student and enrolled. We say that the SID in the enrolled is a foreign key reference to a student's table, right, in the previous page. So let's assume if we want to insert some new data tuples into this enrolled table, and this new data tuple actually covers a non-existing student ID. In other words, we want to insert some data into the table. However, the student we are inserting doesn't exist in the student's table, right? We want to insert one more row into this table. However, the student we are inserting doesn't exist in the student's table. In other words, we are referring to a non-existing student, right? Normally, if we are doing this kind of insertion, we should reject this insertion because we are referring to a non-existing student, right? So as to maintain the referential integrated constraint. So this is very important. In the ER model, in both ER model and relational model, we need to model this referential integrated constraint very seriously. It can help us maintain the systems very well. This is about insertion, right? How about if we do the deletion? Let's assume in this table we have this data tuples for the 53666 for the Jones, this student, right? Right now, these tables are very healthy because all the students we are referring to, they all exist in the students table, right? Let's assume right now we do a updating of the students table. We delete this data tuple from the students table, right? We deleted this row. Before we do the deletion, everything is good. However, after we do the deletion, there will be some problems because in the enroll table, we have 3 data records about the students, right? We want to delete. If we do the deletion of the students here, what should we do for the students in the enrolled table? It's very similar for you, right? When you are using some social media like Facebook. I know many of you may have Facebook accounts, and you may also upload lots of messages, lots of photos, and also posts in Facebook. Let's assume one day, if you plan to delete your Facebook account, right? And how will Facebook handle your photos, your posts, and your messages? It's very serious for you, right? I mean, it is your own information, it's your privacy. You may assume that after you delete your account, everything about you should disappear in Facebook. However, if Facebook doesn't do any action for the remaining information for you, right? For the tables, for the posts, after you delete your account, then you may think it will be a problem, right? It's similar here. If we do deletion of the students here in the students table, however, we do nothing for the enrolled table, then we are referring to a non-existing student. And for a student who doesn't in the table anymore, his private information is still here, right? It will not be good. So once we do the deletion of the students, so we have different options. The first one is very simple. If we delete one student, we will also do the deletion of all the enrolled tuples in the enrolled table that refers to the students. It's very easy to understand, right? If we delete this student here, all the tuples here should also be deleted as well. It's one option can provided by SQL. Another option is that we can disallow the deletion of a student that refers to by some other tables. Right? If we plan to do the deletion in this student table, we find that this ID has been referred by some other tables and some other data instances. This one is referred in here in these three places. Then the system can disallow the deletion of his students. He may say that this student has been referred many times in other tables. We cannot delete it here. This is another option. The third one will be we can set the SID in the enroll table to be with a default ID. This is also a possible option. Right? If we delete this student in the students table, how can we handle the data here? We can just remove this SID with some default IDs, the 00000, right? To say, okay, this information is about some student we have deleted already. This is another option. Or in SQL, we can also set this ID in the enroll table to null, right? If so, then we can set this one as null in this column for the students, right? This is about the deletion. We can have different options, and depending on which one you choose, we'll say why and how can we choose these kinds of different options in the following page. Besides the insert as well as deletion, and you may also wonder how can we handle if we do some updates of some data tuples for the students. Now, if we want to change this SID as shown here, and we can have similar options as this one, right? It will be similar, right? We can also have different options. If we do the update of the SID in the students table, we can also update all the enrolled tuples refers to it, or we can disallow this update, or we can set some default values for the new ID, right? And extension. So we can have different mechanisms in SQL to achieve these different options